Hello, today we're going to continue chapter 9 with section 9.1. We're going to continue talking about the ellipse. We're going to start with a new vocabulary term, the eccentricity. We usually use the letter E to represent eccentricity, and that is the measurement. It's a measurement that describes the shape of the ellipse. Basically, it uses the values A and C. So a reminder that A is the semi-major axis, that's half the major axis, and C is the distance from the center to a focus. So that's A and that's C. And the formula to find E is you do the value of C divided by A. Now you'll notice in this diagram you can see clearly that C is going to be shorter than A, which means the number on top is going to be smaller than the number on the bottom, which means this formula will always give you a fraction that's between 0 and 1. So the eccentricity of an ellipse will always be between 0 and 1. Now, the value of that number will tell you information about the shape of the ellipse. So, for example, if E is really close to 0, so you can imagine a number up here on top that's really small and here maybe is a lot larger. That would mean the focus is really close to the center. So that would mean that the foci are close to the center of the ellipse if E is close to 0. And what that graph looks like is it looks very close to a circle. It's like it's not very stretched out much at all. So this would be an example of an ellipse with an eccentricity of 1/5. It almost looks like a circle, but it is a little wider than it is tall. Now, if the eccentricity is close to 1, that means that the number on top is almost as much as the number on bottom, which would mean C is almost as much as A, which means the foci are far from the center and really close to the vertex of the ellipse. Now, in that case, the ellipse would be very stretched out. So this is an example of an ellipse with an eccentricity of 5/6. All right. So next, we're going to look at doing a type of problem in which you are given some information about an ellipse, and then using that information, you need to graph it and write the equation. Now, depending on the information that's given, the work you do or what you do or how you approach it could look very different. So I'm just going to go through a few examples of different varieties or combinations of informations, and we'll see what happens. And you'll notice that every problem is a little different. So write the equation for an ellipse that has a center at 3, 1 and a vertical semi-major axis of 6 units long and an E equal to 1/3. Then graph the ellipse. So I find it helpful to start drawing your graph as soon as you know some information. So I'm going to draw a center at 3, 1, and then I'm going to draw a vertical semi-major axis. So vertical means up and down. Semi-major axis means half the major axis, so this is going to be in the middle, which means 1, 2, 3, 4, 5, 6 units above and 6 units below. Those right there will be the endpoints of my major axis. So the major axis is 12 units, semi-major axis is 6. So that's what I know, but I don't really know how far it's stretched out horizontally at all. And that's where this eccentricity number becomes helpful. Basically, this number right here is the value of A, and I don't know the value of B, nor do I know the value of C. So what I'm going to do is I'm going to use, basically the general approach for all these problems is I'm going to use this formula and this formula to find any of those missing values. So you'll notice I only know A, which makes this formula not too useful because it would still have 2 variables if I plugged in a number there for A. However, I do know E is 1/3, so I'm going to start by using this formula right here and plugging in a 1/3 for E, and then I also plug in a 6 for A. Now you can see here that 1/3 is equal to C over 6, so what fraction, over 6 is going to be equal to 1/3, and you can solve that. You could either cross multiply or you could realize you just need to scale that up by 2 to get that C is 2. Once you have that C is 2, you plug it into this formula along with A is 6, and you can solve for B. B squared is 32, which means B is the square root of 32. And then the square root of 32 is like a little less than 6, more than 5. So it's, 5 point something. So if you are graphing your ellipse, that's going to be 1, 2, 3, 4, 5, and a little bit more, close to 6. You can use your calculator to get an approximation, but it's close to 6. So those are going to be the endpoints of my ellipse here. And then I'll draw, if I can here, I'll draw an ellipse that goes through those 4 points, and now there's my graph. And then to write an equation for this ellipse, it's centered at 3, 1. So there's where 3 goes, x minus 3, and then a y minus 1 there. And then in the x direction, it's stretched out by the square root of 32. So in the x direction, I'm going to square that number and put it down there. And then in the y direction, it's stretched out by a factor of 6. That's the semi-major axis. So that's going to be 6 squared down there is 36. The only thing left for this one, it didn't ask you to plot the foci, but it's very easy to once you know C. It's 2 units away from the center, but it's not in this direction because the foci are always on the major axis, and for this one the major axis is vertical. So for this one the foci would be 2 units above and 2 units below the center. So if it did ask you for those, that's where they would be. All right, let's take a look at another one here. It says there are vertices at 6, 0 and negative 6, 0, and there are foci at 3, 0 and negative 3, 0. So vertices at 6, 0 and negative 6, 0, and foci at 3, 0 and negative 3, 0. And then from that, you can easily identify the center because it's halfway in between the foci, or it's halfway in between these vertices at 0, 0 is going to be the center. And then you can identify what we know here. C is going to be 3. That's the distance from the center to a focus. So you can, from this, you can tell that C is 3. And then this would be half of an axis, and because it has the foci, this is the bigger axis, or the semi-major axis, so this is going to be A, and A is going to be 6. And then from there, once I know those two, I can plug both them into this formula to find B. Notice this time I wasn't told any information about the eccentricity, and I wasn't asked to find it, so I didn't need to use that formula. I already have what I need to find the missing part that I need. So 36 then minus 9 is going to be 27, and that's the square root of 27, which is a little more than 5. So I'm going to go up 1, 2, 3, 4, 5 point. I'll use my calculator to get 5 point something, and those will be the vertices of my ellipse. And then I can draw an ellipse through all 4 of those points, and there is my graph done. And then the only thing left is write the equation. Since the center is 0, 0, that means it's going to be like x minus 0 squared, which is just x squared, and y minus 0 squared is just y squared. In the x direction, we had a was 6. So that's going to be 6 squared beneath x squared. And then in the y direction, it was the square root of 27. When you square that, you'll just get 27. So that goes underneath y squared. All right, let's take a look at another one here. So for this one, I know the center is at 0, 0, the eccentricity is 0.5 or 1/2, and A is 10. So the center is at 0, 0, A is 10, so 10 units away is the major axis, but I don't know which direction that's in. Well, we'll come back to that. I do know something about the eccentricity, so I'm probably going to use that formula there. And let's see, I know E, I know A, so let's use this formula to find C. So I plug in 1/2 for E, I plug in a 10 for A, and I get this equation right there. I solve it for C, and C is 5. I then plug that into this equation here of 5 for C and a 10 for A, and I get that B is the square root of 75. Now, the only thing, though, is I still don't know which direction is A and which direction is B. So it might be that A is horizontal, in which case my equation would look like this. And in which case it would be 10 units horizontally in the x direction. and the square root of 75 is a little less than 9, I think. So that would be about 8 units. Or sorry, close to 9, 8 point something. So that would be like there and there. So my graph might look something like this. Now, based on the information, though, I don't know whether it's going to look like that or like this, because I don't know which one's going to be A and which one's going to be B based on the information. So it might be that 10 was in this direction, and then the square root of 75 is going to be in this direction. So it could be either one of these. So for this one, there are actually two possible answers. And here they both are, and there are both of the graphs. And then for this one, if you were asked to plot the foci, it would be 5 units away from the center. In this case, the major axis is horizontal, so the foci would be there and there. And in this case, the major axis is vertical, in which case the foci would be there and there. And last one here, if the foci are at 3, 1, and 3, 9, and the minor axis is 6, how do I graph that? So I'm going to start by graphing what I know. The foci are at 3, 1, and 3, 9. And now that's all I really know about this picture, but I know the center will always be exactly halfway between these. So if I count how far apart they are, they're 8 units apart, so I go 4 units from each, and that's going to be where the center is. Then I know the minor axis is 6 units, and I know that's not going to be this way. The minor axis does not have the foci on it, so the minor axis is going to be this way, which means the minor axis is going to be right there. And notice that that's the entire minor axis, not just the semi-minor axis. So 6 units to the left and right of the, or 3 units on each side of the center will give me that axis of 6 units. So there are the endpoints of my minor axis right there. And then let's see, I then can identify that C is equal to 1, 2, 3, 4. That's how far apart the foci are from the center. And the semi-minor axis B is equal to 3. That's how far that vertex is from the center. I then plug both those numbers in to this to find the value of A, and I get that A is 5. And I know since the foci are aligned vertically, that means the major axis is going to be aligned vertically. So that's 5 units above and 5 units below the center. And now here I have all 4 vertices of my ellipse. So I draw a curve through them, and there's my ellipse. And then the equation here, let's see, the center's at 3, 5, so that's x minus 3 squared and y minus 5 squared. In the x direction, the stretch is 3, so underneath x goes 3 squared. In the y direction, the stretch is 5, so underneath the y term, it goes 5 squared, and there's the equation for this ellipse. So you can see for each one of these last 4 examples, depending on what information we're given, the approach is different. Basically, the key is you're always going to use some combination of these 2 formulas, plug in what you know to find what you're missing, and then draw what you know. And I find the pictures often help me write the equation. So always be sketching your graphs as you go. That's it for this lesson, and please let me know if you have any questions.